Welcome to clickmyproject.com. Our project title is on automated dynamic offset for network selection in heterogeneous networks. Now I explain about the abstract of our project. Our project abstract is complementing traditional cellular networks with the options of integrated small cells and Wi-Fi access points can be used to further boost the overall traffic capacity and services level. The small cells along with the Wi-Fi access points are projected to carry over a 60% of all the global data traffic by 2015. With the integration of small cells on the radio access network levels, there is a focus on the providing operators with more control over the small cell selection while reducing the feedback. Altogether, these issues motivated the needs of innovation distributed and anomalies associated policies that operated on each user under the network operator's control, utilizing only a particle information yet achieving a near optimal solution for the network. In this process, we proposing a load-aware network selection approaches applied to automated dynamic offset in heterogeneous networks. In particular, we investigated the properties of the heterogeneous Bayesian game framework in which the macro cells dynamically choosing offset about the state of the channel in order to guide user to performing the intelligent network selection decision between the macro cells and the small cell networks. We deriving the analytically the utility related to the channel quality preserved by users to obtaining the equilibria and compared it to the fully centralized optimal. The fully channel state information of the non-cooperative models. Building upon these results, we effectively addressing the problem of how to integrately configure a dynamic offset which optimizing the network's global utilization, which use and maximizing their individual utilizes. One of the technical contribution of in this process lies in the obtaining the explicit characteristics of the dynamic offset at equilibrium and the related performance in the terms of the price of this algorithm is for finding the dynamic offset of a stackle model. Now I explain about flow diagram of our project. Our flow is first one is a network formation. Nodes are created for sensing and receiving the data packets. TCP is used for establishing the connection between the source and the destination. The file transfer protocol FTP and randomly choosing the different source and the destination connection. Networks are formed with a given range of the sensors. Nodes are grouped automatically depend upon their radio waves. Agents are formed for a group registration. The simulation is done in NS2, that is network simulation version 2. Next one is macro cells. The macro cells contain a number of small cells. The macro cells covers the number of small cells region. The small cells contains n number of users. The users have a sender and the receiver. Next one is in a ZRP protocol. The ZRP protocol is we proposing in this modules of ZRP protocol was implemented. The zone based routing it is an ZRP combining the advantages of proactive and the reactive approaches by maintaining an up-to-date topological map for a zone centered on the each nodes. Within the zone routing are immediately available. The destination outside is a zone ZRP employing the route discovery procedure which can be benefits from the local routing information for the zone. The ZRP reducing a traffic amount of compared to pure of a proactive or a reactive. The routing of the node within the zones are immediately available. The ZRP is able to identifying the multiple routers to the destination which provide increased reliability and performance. It ensuring that the routing are free from the loops. It is fault protocol with reducing the congestion and the overhead uses to related the hierarchical protocol. If the user type protocol is find means if the root discovery means it will send a finding on a next best hop using particle swarm optimization. Here we finding the position, velocity, speed of an each node. If the data collection is based on the energy of a node, then the destination nodes if the communication sent to the destination node. Next one is a performance measure. The performance measures in three metrics: the throughput and energy consumption and delay of our project. Now I explain about the output of our project. First open the terminal window. Now I change the directory. So type cd space heterogeneous. Now change the directory root into heterogeneous. Then type ns space main.tcl. Now run the main file. Here the particles from optimization algorithm is done using the EZRP protocol. Here the position, velocity, speed and the energy of a node is find here. Each and every node is find here. This is nam console. This is how.nam. Now this is zoom in button, this is zoom out button, this is rewind button, this is playback button, stop button, this is play forward button and fast forward button, this is time simulation and it is speed setup. Now I play the project. Here the macro cell is deployed here. The one macro cells cover each small cells. Here I deployed 4 small cells. The one small cells cover n number of users. Here the 4 types of small cells are deployed here. The nodes are randomly deployed, but the macro cells and the small cells are statically deployed here. Now the source node sends communication to the small cell node and the small cell sends communication to the macro cell. The macro cells find which small cells containing a destination node and then sends to the small cell. Now the macro cell sends communication to the small cells. The macro cells covers all small cell region. Now the small cells sends communication to the destination node. The communication is end. Now I explain graph. So type xgraph space throughput.xg. This command is used to display our throughput of our project. Next one is xgraph space delay.xg. This command is used to display our delay of our project. Thank you for listening. Our demo is completed.